Hi there, welcome back. So today we're talking about mixtures. And so if you take all of matter can either be classified as pure substances, which means made of only one type of particle. Particle could be an ionic compound or a molecule or an atom, an element, or it could be a mixture. So now we're going to talk about what a mixture is, the different types of mixtures, and then how to separate them. That's what we'll go over today. So right at the top of the page, you see that there's the definition of mixtures. What are mixtures, right? So mixtures are, they're not bonded together. So we just call them combinations of substances. So combinations of substances that, and this is, I'm gonna make this, I'm gonna spell this right too, that can be separated by physical means. And so we'll go through what those physical means are on the next page, the chromatography and distillation and filtration. What do we mean by physical? So the opposite of physical would be considered chemical. We can break water up into oxygen and hydrogen, but that would be separating it by chemical means. At the end, they're different substances. All of these mixtures that we're going to look at today, you can separate them and the components don't change. They were mixed together and then we separate them, but the components are still the same particles. So there are two main types of mixtures, and those are homogeneous mixtures, and we can see down below heterogeneous mixture. So homogeneous or homogeneous and heterogeneous. And so we'll talk about what those two mean. And the first example of a homogeneous or homogeneous mixture that we're going to talk about is called a solution. Okay, so what is a solution? Solutions are homogeneous mixtures. So homogeneous mixtures in which one, which we're going to call the solute, is completely dissolved in another, which we call the solvent. Right? How do I remember like which one is which, the solute or the solvent? I always think you dissolve the solute. So if we're thinking about the example that we have here of salt water, right? If we think of salt water, salt is the solute. You add the salt to the water. You dissolve the salt in the water. Solutions, when we often think of solutions, we think of something like salt water, sugar water, taking a solid and mixing it into a liquid. That doesn't necessarily need to be the case. Solutions can be made of solids, liquids, or gases in any combination. Okay, air is a solution that is made of gases, right? So what makes a solution different than the other ones on this page, different than a colloid and a suspension? And that's because solutions are what we call homogeneous or homogeneous, right? So what does that mean? A homogeneous mixture is in which the substances are evenly distributed and have a uniform composition. So evenly distributed and have a uniform composition. So think about if you have salt water and you take a spoon and you take out a sample of that salt water. It's the same percentage of salt in water as the rest of that's left in the beaker, right? If I were to take a sample out of that beaker there, the percentage of salt in the sample that I removed is the same as the whole beaker. Why? Because the salt and the water are evenly distributed. Okay? So just as to get into a little bit more detail about that difference between the solute and the solvent, right? What is the solvent? A substance in which the other material dissolves. Right? The solvent, we often think of it as the liquid, but it doesn't have to be. And that will form, of course, a solution. And then the other part of that is the solute, a substance that is dissolved in the solvent. Okay? So when you practice this, I'm going to ask you to identify which one is the solute and which one is the solvent. So now we go down to the two other types of mixtures, and those are heterogeneous mixtures. So let's decide what a heterogeneous mixture is, and then we'll talk about the two different types. If you look at what we talked about before, the homogeneous mixture, a homogeneous mixture was when the components were evenly distributed. So guess what a heterogeneous mixture is? It's when the substances are not evenly distributed and the original substances are physically distinct. Meaning you can see the original substances that were used, okay? So we have two different types of a heterogeneous mixture where the particles are not evenly distributed. The first is a colloid and the second is a suspension. A colloid is sometimes thought of as maybe in between a solution and a suspension, because a colloid and a solution are going to have something in common. So colloids are mixtures that are halfway between a solution and a suspension. Particles appear to be distributed, so you usually can't see them, the individual particles. You don't actually see them with your physical eye, but upon closer inspection, reveals a heterogeneous mixture. Like if you were able to zoom in with a microscope, particles are not large enough to settle out, right? And so the example that we have for this is homogenized milk, right? So homogenized milk, the particles, think of milk has a lot of things in it, but the two things that may settle out would be the fat and the water. So the milk fat and the water. We know that fats are lipids. Lipids are nonpolar. Water is very polar. Those two do not mix. And if you take milk right from a cow and you let it sit, it will separate so that you get the skim milk on the bottom and you get cream where there's a heavy fat content on the top. And so they would settle out. That would be more an example of a suspension. But what you can do is you can break up those fat particles and make them into much smaller individual fat molecules. And then because the particles are not as large as they would be in a suspension, they actually don't settle out. Okay? So then the last one that we're going to talk about is this, the other type of heterogeneous mixture, which is a suspension. And the suspension where the particles are so large that they actually do settle out. So suspensions are also heterogeneous. A heterogeneous mixture in which the particles do not dissolve. So we do not call them being dissolved. They're mixed together, but they don't dissolve and they are not evenly distributed. And over time, the particles in a suspension can in fact settle out. What do we mean by that? It means that they will eventually sink to the bottom of the container, right? And so if you look at the example here, right, muddy water is a good example of a suspension. If you just let that sit for a few hours, the particles of mud, so the particles of the dirt that makes it mud, are so large that they will eventually, gravity will take hold of them and they will sink down to the bottom, so that you will have relatively clear water on top, but then a layer of the dirt, the mud on the bottom. Most suspensions are solids in liquids because they would be larger particles, but you can also have it be two liquids or even a solid and a liquid and a gas, or even a solid or liquid in a gas. These, we have a lot of examples that we see all the time. A lot of them will use liquid as the solvent or the medium in which the particle is mixed into. That doesn't have to always be the case. Okay. So what makes a mixture is that it can be separated by physical means. So what the heck do I mean by physical means? Well, there's three of them. 3 ways that we can separate out a mixture, and we haven't changed what the mixture was composed of. We just have moved, one to one side and one to another. So the first one is called filtration. And filtration is something that you have used tons of times. If you've ever made pasta and you've poured the noodles that are in the water into the strainer, that's a filtration, because it separates a solid from a liquid by physical means. The particles are too small The solvent particles are too small and they will go through the filter, but the solute or the noodles or whatever is too big. It won't go through the filter and it will stay at the top. So you can see the example here. It has to be an insoluble solid. So example, you can't use filtration to separate out salt water because the salt will just go right through the filter. But you could use a filter to separate sand and water. Okay. Well, there's some vocabulary words here that are good to know. We talk about the liquid that goes through as the filtrate. And sometimes we have to do more work with the filtrate. Okay. Distillation. So if you've ever heard of distilled water, this is how they make distilled water. So this is a process by which you separate two compounds because they have different boiling points. Okay. In this example, in this picture here, let me get that so you can, pause and write down the definition. In this example here, you have tap water. And tap water we think of as being, well, that's just water, but there's also some compounds that may be in the tap water that were used to clean it, that were used to sanitize it. And if I boil the tap water, what will happen is just the water, just literally the molecule composed of 1 oxygen and 2 hydrogen will boil, will turn into a gas, and then it goes through this tube, this condenser. And in the condenser, it's the tube within a tube, and in between those two tubes is cold water. So what that does, that takes energy away from the steam, and that water goes from being a gas to a liquid, goes back to the liquid form, and here you have just pure, what we would call distilled water. This is how you could purify salt water. You could use distillation. This is also how a lot of alcohol is made. We're using alcohol nowadays for a lot of hand sanitizer, but also like ethyl alcohol for drinking beer, wine, liquor, things like that. And then the last technique that we use to separate out a mixture is called chromatography. And when you think of that prefix chroma, you think color. And it's often chromatography is often used to separate solutions that have different color components, but it doesn't have to be. Chromatography is used an awful lot in college, in research, to separate out a mixture. So when I was creating chemicals in college, I would, do a reaction and I would hope that I made one thing, and usually I made 5 or 6 other chemicals, other substances that I didn't really want. So I would have to separate them out. And I did that through chromatography. Chromatography is a process that uses to separate a mixture by passing it through a medium. The picture that you have is paper chromatography. So the medium is paper. There's also TLC, thin layer chromatography, or column chromatography. The difference is that the medium, one of the components of the mixture will move at a different rate through the medium, and it's often because of polarity, because one of the substances is more or less polar than the medium, or the liquid, the solvent that the chromatography paper is put into. So if you look at this picture over here, this is a sample of what we would see if we did chromatography with like magic markers. So magic markers, when you take a purple magic marker, sometimes it's a purple pigment in there. Oftentimes it's not. It's a blue pigment and a red pigment, and when you see them together, it looks purple. So what this would be an example of putting, you would put like a little piece of that pigment. Let me get like a purple here. If we put like a little piece of purple pigment on that paper, and then you would take this strip of paper and you'd put it in, sometimes you could put it in water or ethyl alcohol or something non-polar like a hexane. And it's kind of like a paper towel. As the liquid moves up, the components in the sample that you're trying to separate are either really attracted to the liquid or really attracted to the paper. And that will then separate them out. Okay. We'll look at a little bit more of these when we're in class, how these techniques are used. But these are the 3 ways that we separate out a mixture. And remember, mixtures can be solutions, which are homogeneous, or heterogeneous, of which there's 2 types, colloids and suspensions.